In this video, we're going to talk about midsegments. So we're going to talk about midsegments of triangles, and then we're going to talk about midsegments of trapezoids. So let's start by drawing a triangle in here. And let's call it triangle ABC. And I'm going to find the midpoint of side AB. So there's the midpoint. We'll call that point D, and I will show that it's a midpoint with tick marks. And I'm also going to find the midpoint of AC. So there's the midpoint of AC. Again, I'm going to use tick marks to indicate that it is a midpoint. Now, what I'm going to do is I'm going to take these two midpoints and I am going to connect them. Okay, so let's label that point E. We have a midsegment of this triangle. So we can see that I drew two midpoints, I connected it with a segment, and we call it a midsegment. So what we can do next is we can also find the midpoint of side BC. So let's find the midpoint of side BC, give it some tick marks, and I can connect the midpoint at D and the midpoint at F to have another midsegment, and I can connect E and F to get a third midsegment. So since there's three sides of the triangle, there's going to be three midpoints, and I can connect all three midpoints to get three different midsegments. So our first question here, how do the four triangles created by the midsegments of a triangle compare? So if we take a look at this, it kind of looks like they're going to be congruent. And in fact, we could prove using our triangle shortcuts that we've used in the past that all four triangles formed are congruent. So that's kind of cool. And how does midsegment DE compare to segment AC? So our picture is a little bit different here. So we're going to change this to how does midsegment DE compare to segment BC? All right, so if we were to measure DE and I was also to measure BC, we would notice that DE is half the length of BC. Segment DE is half the length of BC. All right, so, and that's going to be true for every midsegment. So if we look at midsegment EF, the one that goes in the same direction, my picture's a little bit off, but we can see here, EF is going to be half of AB, and DF is going to be half of AC. So since each of these is half, I could add some more tick marks. I'm going to add 3 tick marks there because this segment DE is half of BC, so it has to be equal to each half of that. And we'll put 2 tick marks here, and we'll put 1 tick mark here to indicate that DF is equal or congruent to segment AE or segment CE. All right. So here we have a triangle with the 3 midsegments drawn in. This is our triangle midsegment conjecture. The 3 midsegments of a triangle divided into 4 congruent triangles. All right, and then something we didn't talk about yet, I didn't want to make the picture too messy, but the midsegments of a triangle is parallel to the third side. So this midsegment here is parallel to this side of the triangle here. So these are parallel. All right, and this midsegment here is going to be parallel to this side of the triangle here. So these are parallel. So remember, we already figured out that the midsegment is half of the other side of the triangle. And then our last midsegment over here is going to be parallel to this side of the triangle over here. So we'll color code that green. Okay, and a midsegment of a triangle is half the length of the third side. When we say the third side, each midsegment, for example, this midsegment, it goes through this side of the triangle and also this side of the triangle. So when we say it's half the length of the third side, we're talking about the side that it doesn't go through, which is on the bottom there. All right, so that's it for this video. If you had any questions, make sure you ask. It's very important that you start thinking about how to apply these to solve some problems. And we'll see you in the next video.